Hello viewer, welcome in this session where we are going to discuss how we can calculate the protein content using a calibration curve. Uh, this is exactly how to calculate the protein content using a calibration curve from this standard of BCA, which is bovine serum albumin. So now these are the data that we have gathered. For example, the we've calculated the standard different concentration. We prepared these concentrations, okay, and we check their absorbance at 70 750 nanometer, which is typical. Then the concentration is microgram per milliliter. We prepare these standard solutions. Now, after calculating their respective absorbance, we now go ahead and plot a calibration curve. We want a calibration curve which is like this, this one. We want to build a calibration curve which is like this. So how can we uh, have something like this using Excel sheet? Because it is in Excel sheet that we can calculate the unknown concentration from the calibration curve from this data. It is from this one we can check the unknown concentration of a particular sample. For example, this is food sample, food samples again. Okay, we can take it and move it here. Okay, we can shift it to this side to save time. Okay, then this is the food sample, which is, for example, sample one, sample two, sample three, sample four, sample five, and sample six. Then, for example, this is the absorbance that we got the absorbance at 750 nanometer. And what we are looking for is the concentration of protein concentration in microgram per milliliter. Okay, that's all we are going to calculate. After we have constructed these two tables, we now go ahead and plot the curve, the calibration curve from this standard data. Yes, from this standard data, we are going to calculate the calibration curve. We come here and select all these data and we go to the insert. After going to insert, we go to this insert scatter plot. Yes, scatter plot. Then we check this one. Okay. We choose the one that is made of two. Mm, scatter plot. We can even choose more scatter plot, and we choose this one. Yes, we choose this one, okay? After double clicking on it, it has appeared. Then we are going to insert all axis. We check that this the concentration should be at this level. Okay, then the absorbance should be at this level. It is from 0 to, for example, 1.2. Since it is, yes, 1.2. Yes, 1.2 is the maximum. Okay, since the highest here we have is 0.9. This is the absorbance, and here we have concentration. Then we are going to name this chart. How do we do it? We double click in this title, then we insert the name of the the calibration curve. This is the protein calibration curve using BSA. Okay, then we click here, the name is gone, is inserted. Then we come here to just put it at the center. We can even drag it. We can drag this one and put it at the center. Okay, then we are going to insert the axis, y-axis and the x-axis, and we name their names. We come here and do insert. Then we click here at this button plus, and this option appears. We click here axis titles. Okay, then we close it by now. Here it is the concentration. Okay, this is protein concentration that is below. We come here and double click in this title, and we paste it here, control V. That is control V to paste. Yeah, that's how we can paste it here. Then we bold it, and we are going to insert the title here also. This is the absorbance. Okay, then we come here and select here, copy, and you come here and paste it here. You paste it here, then you bold it. Okay, you have to bold it. We are going to bold it so that it can be readable. Now, for us to have a trend line on this dot, we have to click here and we go to this add, then we go to this trend line. Okay, this is the trend line that we have added. Now, to display the equation on this chart, how do we do it? So because we need also the equation, we double click on it. We double click on this chart. We click here, we do add, we can even go to this that bottom down. We go to this display equation on this chart. How did I reach here? I came here, I click on this line, then this option appears, trend line options. That's where you go. This is about the visibility of this chart, and this is the car, about the car. Before initially we were here. If you want to not to use the dash type, you can use a straight line like this, or you can use this dashboard, or you can change any other type of line that you want. Okay, you can even decide to use this one. Okay, now we are going to insert the equation on this calibration curve. Now we have to go and choose this option, display equation on chart. Then I click here. If you display also this arrow square, which is regression line coefficient, this R square. It indicates that 0.999 is close to the straight line, which is very good. This is where we have linear, like we have a linear relationship. Our equation, our curve is not a polynomial one. But if R is below 0.9 or closer to 1, definitely we are not going to have a straight line. We can have maybe a concave up, concave down, something like that, which is a polynomial. Now we are done. This R is not needed by now. But what we are going to need most is this equation, y-intercept. Y and its equation. Now, after obtaining this calibration curve, we are going to now calculate the protein concentration of the unknown samples. So these are our food samples. So, okay. Then, for example, we've determined the sample one, then we've gotten that it has 0.25 absorbance. Then here it had 0.32 absorbance. Then this one has 0.14 absorbance. Then this one had 0.45 absorbance. Then this one had 0.67 absorbance. Then this one had 0.82 absorbance. Then, since we have the corresponding absorbance, we have gotten this value from the machine spectrophotometer. Now we are going to calculate the protein concentration of these samples using this calibration curve. What we are going to do. The way these things work is that this y-intercept, we need to solve x. This protein concentration is going to be considered as this protein content which is here. Now, this y is going to be considered as the absorbance. Yes, now let us solve. If we want to solve for x, if we want to solve for x, we go ahead and do it. Now, y equals 0.17 0.1174 x and minus 0.1265. Now, if we solve for x is going to have, now we say x is going to have y over, that means that should be y minus since this one is minus, to this side it we have plus it will be y plus 0.12 0.12 0.1265. Then here we have divide. This one we have definitely divided by 0.1174. Okay. We can divide it together. That is y. Then all this over 0.1174. Now that's how we can get the value for x, which is the protein concentration that we are looking for. Now, the first one the first sample one, x1, which is x1 equals, we are going to take these absorbance. Since y stand for the absorbance, it will be equal to this absorbance, which is 0.25 plus 0.1265 divided by 0.1174. Okay, then it will be equal to this one. Now the way to do it, now we have to write x1, then here you have to come here and type equals um, 0. You have to come and take this one, 0.25 plus 0.1265 over 0.1174. Then we click enter. Then the value is appearing here. This is x1. Now x2 will be equal to equal sign. Then we click 0.25 plus, no, that should be not 0.5, but it is this one. This one, it is this one, 0.32 plus 0.1265 divided by 0.1174. Then this is exactly x2. Okay, x2. x2, this is x2. Now for x3, we do the same, and as well as x4, and so on and so forth. Okay, this is enough. This is x3, x4, x5, and x6. Then here we have to put equal sign and look for this is 3. We open parentheses, we say this is x3, this is it, plus 0.12, 0.12, yeah, plus 0.1265. Okay, close the bracket and divide it by 0.1174. Then we click enter. Now to save time, sometimes we may need to put this one. We put this value as 0.1265, and we put also this one as 1174. For us to save time now, we are going to put equal sign, we open parentheses. This is 4, we click here, then plus this one, okay, then we close the bracket, then we divide by this one, then we click enter first. This is to save time. Then equal sign, we open parentheses, then we put this is x5, we click here, we add this 0.112, then we divide it by this one, then we are free to go. That is 6. Then we are heading to the last one. We click in equal sign, we open parentheses, then we click here 6, then we add this one, then we close the bracket, we divide it by this one m, then we save time. These are now the protein concentration of the animal. We come here and put it here, copy it, put it here, okay, come here, copy it, and we put it here, we come here, copy it, and we put it here, we copy it, we put it here, then we enter. Yeah, that's why it was displaying error. Then we copy the fourth one, we copy it, we paste it here, we check what's wrong with the formula. So what's wrong with the formula? We now go ahead and solve it. This is it. We have added this one, then we have divided by this one. Okay, that is the same thing. Then you go to the fifth one, we copy this one, we paste it here. We check what's wrong with the formula. If the formula is wrong, we choose this one, we add this one, and we divide by this one m. Okay, then we head to the last one. This is it. We copy it, we paste it here. If it is displaying error, you have to repeat whatever you did since it is the same. If you know how to do it, it is very fast. And we divide by m. Okay, click enter. It's the same. So that's how we can get the protein concentration of the animal from the calibration standard. Okay, thank you for watching.